is video number 5 for chapter 8 in chemistry. And this video, in this video, we're going to be covering single replacement, or sometimes they're called single displacement reactions. Now, in this type of a reaction, you will always have a compound, and it will react with an element. And then if the reaction occurs, you will produce a different compound and then a different element. Essentially, the element is going to push one of the partners out of the compound and take its place. That's why we call it displacement or replacement. It takes its spot. So when you see the general format, hopefully that'll make sense to you. So for example, here you have the compound AX, and it is reacting with the element Y. Now, when you look at that compound AX, if we assume that the first part of the compound is positive and the second part of the compound is negative, we're looking at Y, and if we look at what happens, Y took the place of X and got rid of X. X had to leave the compound. So what we formed was a new compound, AY, and X was the element left on his own. Now that can happen another way if we look at it as we still have compound AX, but now it's going to react with a different element. We're going to say B. Now this time B will take place of A. So B is going to replace A and leave A on its own. Now, A and B would have to be the same type of element. And if they are written first, they're usually metals or the positive part of the compound. The X and the Y, since they're written second, are usually the nonmetals or the negative part of the compound. So one element will displace a similar element. If you noticed, in our first reaction, I'll call this one number 1, Y took the place of X, and X and Y were both nonmetals, similar elements. In our second reaction, reaction 2, B took the place of A. B replaced A, and A and B were both positives or metals. So that's what's going to happen in this type of a reaction. Now you're going to have a list to tell you what can react with something else. So the activity series is what we use to decide what can push something else out. They are listed in order of decreasing reactivity. So if you can take a look at your blue sheet, you'll see a list of metals. And I'm not going to go through everything, but you'll notice that there's lithium at the top, followed by rubidium, followed by potassium, and I'll just do the first 4, then barium. What this means is, if an element is going to try to replace another element, it has to be above that. So for example, lithium would be able to replace any of those falling below it. So lithium can kick rubidium out of a compound, lithium can kick potassium out of a compound, and lithium can kick barium out of a compound, and it can kick anything else that falls beneath it. Rubidium, the only element rubidium is not capable of kicking out is lithium, because rubidium is lower than lithium. But anything that is lower than rubidium, it can kick out. Potassium can kick out anything that falls below it, but not anything above it. That's what that means to be in order of decreasing reactivity. We'll do a few examples here in just a moment so that you can see what that looks like. Now, the halogens, the nonmetals, these are the only nonmetals you're going to have to worry about. And the halogens are in order of the same order they live on in the periodic table. So the halogens go fluorine, then chlorine, then bromine, and then lastly iodine. We don't worry about astatine too much, but you could add it into the list. Now, fluorine has the ability to replace anything that lives below it, which is all of the halogens. Bromine, on the other hand, can only replace those that are below it. So bromine can kick iodine or astatine out of a compound. But bromine is not strong enough to kick chlorine or fluorine out of a compound. Okay? So, continuing with our examples, we'll see how much practice you guys, or how this works. So you're going to need your blue sheets to help you do these. And when we look at this first example, A, we're going to look at our compound, which is iron 2 sulfate, and that is reacting with zinc. Now you always want to look at the single element and decide if it's a metal or a nonmetal. So looking at your periodic table, you'll see that zinc is a metal So it's going to try to take the place of the other metal in the compound, which is iron. Now, in order for zinc to be able to replace iron, zinc would have to be above iron on the blue sheet. So look at your blue sheet, and is zinc higher than iron? Okay, since it is, this reaction will happen. So the new single element, the one getting shoved out of the reaction, is iron. Iron is going to be the element all by itself. And we need to pair up zinc with sulfate. Now, you can do this on a scratch paper, but if you remember, the charge on zinc is always a +2, and the charge on sulfate is always a -2. So when I write a correctly balanced equation for that, or formula, I would write ZnSO4. And if I look at my equation, now I can see that it is balanced. I have one Fe on each side, a sulfate is on each side, and a zinc is on each side. And this reaction does happen. If you want to practice the next one, try B. See if you can get copper and magnesium nitrate to react. If there is a reaction, write the products and balance the equation. If there's not a reaction, you would write NR for no reaction. So take a moment, you can pause the video and try that one. We'll talk about that one in class. And then I'm going to do C. Now C involves different kinds of elements. If you look, the single element is bromine. And hopefully you recognize that bromine is a nonmetal. It's a halogen. Now, looking at the list of halogens, bromine is going to try to kick out which of these two things? Well, the nonmetals always try to kick out the nonmetals. So in this case, or the negatives, it's going to try to kick out fluorine. Since bromine lives below fluorine, bromine doesn't have the ability to kick fluorine out of the reaction. So I can say here that there will not be a reaction, or NR. I would like you to try D. And we'll practice this tomorrow in class.